In this system, we studied, we have a coil and we have a capacitor which make a resonant circuit. Resonant frequency is determined by inductive reactance and capacitive reactance, and it is driven by a IGBT. IGBT takes a drive signal through driver is connected to microcontroller takes VCC from this local power supply. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Haseeb Electronics. This is a special requested video to make a lecture on induction heater. In this video we will discuss what is induction heater and how it works. It is an electronic heater cooking system. It uses iron or ferrite cookware as like a magnet. This I have a magnet. The base of the cookware is iron based. Induction cookware have iron base. Why? Because in this system we use electromagnetic induction. When we apply current to a piece of wire, it generates magnetic field. It generates flux. This flux, when it will cut to any metal part, it will induce voltage in the other side. It works as a transformer action. We have a coil and there is a core. Then other side we have another coil. The voltage or current flowing from this coil will cause to generate magnetic flux. This flux lines will cut to the secondary. A resultant in the secondary there will EMF induced. This induced EMF will cause to flow of current. So in this system we use a coil, a piece of wire. We apply current from one side and this current will flow in the coil and it will generate a magnetic flux like my fingers. This flux, here is a metal part, it is in the downside. This is the part of the cooker, our cooking system, and this is the metal part. This metal, this iron core, it is piece of our pressure cooker, our cooking pot, anything. This is the base. When it will come closer to this plate, it will make induction in this plate, and when this plate will take current, so this will cause to generate excessive current flow in this plate because that is iron, and the heavy eddy current will flow there in the plate, and in result the plate will get heat up. So the heat will be generated in the base side of the cooking pot. This circuit we will start from end to back. So here I will put this coil here. This coil is here and here is our cooking pot. So now, like SMPS, switch mode power supply, here we have slightly different technology. It is approximately the same to it works approximately same to this power supply. If we see this, like here we have input filter and protection circuit, bridge rectifier, capacitor, then we have pulse width modulator controller, then we have primary of this transformer, secondary side we have a load. In secondary winding we have some rectifiers and some other equipment that is connected to the other side. But in cookware, in induction cooker, the same here. There is no secondary. There is a secondary, the base of our cooking pot. So secondary side will here. Here it will generate voltage and we will rectify and we will use for other circuit. But in cooking system, we don't have other components. We have just one plate here that is needed to heat up. And here there is a slightly modification for the system and we will discuss now. Here is a coil. This coil and other technology here is used because in this system we need heavy current. To control heavy current, resonant circuit. This coil and this capacitor we use in parallel. Two types of technologies are used. In some heating systems we have parallel resonant circuit, and in some circuits we have series resonant circuit. So most of the time we are using this circuit. Now it is connected here. Here is positive 310 volt, 320, 30 volt, any voltage. And then we have, in this system, we use Igbt, insulated gate bijunctional transistor. Why? Because it is used to take high current at high voltage. So Igbt is used to make triggering. We applied voltage here, and this time the Igbt is off. There will no current flow. We take a signal at Igbt. A pulse will cause to flow the current in this coil. And there is one capacitor in parallel. And when this pulse will off, Igbt will off, we know when the current flow in inductor, it causes to generate magnetic flux and it will expand like this. Here is an inductor. We applied current and it will start to increase like this flux. When we removed signal, this flux will come back, collapse. When it will collapse, it will generate counter EMF, reverse voltage, and the capacitor will charge on the reverse direction. So when it will charge at the reverse direction, what will happen? We will take another circulating current. If first current was circulating like this, now the capacitor is charged in reverse direction, so we will take another cycle like this. We applied a pulse. One pulse we applied on the Igbt and it caused to flow of current, this Igbt, pulse width modulator signal, and it will cause to increase the current flow and it will generate a magnetic field, and this current flow will generate a magnetic flux and a voltage will built in the coil in this way. When the pulse disappeared, the magnetic flux will collapse. When it will collapse, it will come at 0 degree. Capacitor will start charging. When it will start charging, here the capacitor is charged. When this capacitor will charge, magnetic flux will finish. This capacitor will allow another current flow again. First the negative side was here, positive was here. Now this capacitor is charged at negative and positive. So this will cause to flow another current flow but in reverse direction. So when it will start again, so it will make like this. This is called resonant frequency, FO. So this value will determine the frequency of resonant frequency. This coil and capacitor combination here it will cause a resonant frequency FO. So here we apply 330 volt DC positive. This side is connected to Igbt and it is ground. So our first point, this capacitor and this inductor will make a tank circuit. Another point, inductive reactance will change time to time according to the size of cooking pot. If it is a big plate, so it will cause extra inductive reactance. If the size of cooking pot is small, it will change. So in this sense, this pulse will change. So this system will detect a IGBT pulse and coil pulse, and we need 330 volt now. First of all, we have to make 330 volt. Now come here, we have 220 volt. We have fuse, then we have other safeties, and then we have these two lines here on the bridge rectifier, and we take 330 volt this capacitor. So this 330 volt is applied here. We need a pulse, we need a drive signal, PWM drive. Most of the cookers, they use microcontrollers, processors, anything which can take a software to monitor safeties, to monitor temperature. We will discuss step by step everything. They have to monitor different things, and then they have to apply a signal here. Then we have a driver circuit, and this driver is applied here. To power up this microcontroller, we need VCC. To operate this microcontroller, we need VCC. Let's make VCC. I will take phase and neutral. It depends upon the circuit designer, how he is designing. Maybe if I will design, sometime I can use a transformer, rectifier, voltage regulator. Maybe in the next circuit I will use a pulse width modulator. In the next circuit I will use inverter circuit. Maybe he is using transformer. He is taking 220 volt. Then diode and capacitor, and I will apply this VCC here. Ground is connected here. So this 5 volt, maximum circuits, there are 5 volt used. Then they use another supply for this driver circuit. Some of them are 12 volt operated and some of them are 18 volt operated. This 18 volt or 12 volt will be generated from this power supply, and it will apply to this. Sometime here is a transistor, signal transistor. Sometime here is Darlington transistor. Sometime we have IR driver. It have to drive the signal, take a weak signal from the processor and apply to the IGBT. And it have to make a safety for the microcontroller. In case of any damage, any short, it should not reverse back to the microcontroller. So most of the time there is IR technology used. Sometimes they are using transistors because it is insulated gate, but sometimes when it is blast, when it is short circuit, it damages very badly. This microcontroller got VCC 12 volt or 18 volt for driver signal. We have interface. What is interface? It is communication between the human, between the operator, and between the machine. Here are some touchpads for temperature: 200 watt, 600 watt, 1800 watt, something. How he want to use: on, off. Okay, then here may be display. So anyone who will apply this temperature, it will show the display here. Then there is another safety here. Here is a temperature sensor in this area, which will sense the temperature of the cooking pot from overcooking, over temperature. So a temperature signal is fed here. In this temperature signal, sometimes they use thermistor, NTC, or any probe which is very closer to this cooking sheet, and then it will sense the temperature, and it is very finely calibrated to give the temperature feedback. Then there is another temperature sensor for the Igbt, because it is high current driver. Temperature cookware, temperature Igbt. Okay, then some systems they use a current probe here, current sensor. So Igbt, it will sense the current of the Igbt. It depends upon the safeties, how the designer is designing. We have to learn the function. We have to understand the function. If we understand the function, we can do anything very easily. So we will discuss the basic key points to understand the function, to understand the operation of this module. Now, it will sense voltage here. Input voltage, under voltage, over voltage. Under voltage, over voltage. Then it will detect the material of the cookware. This signal will come here, and it will allow the microcontroller to adjust the switching frequency, because the iron have different frequency. If anyone put with aluminium, so for more safety it will cause, otherwise the reverse flow will damage the system. Then it will sense the AC current, average AC current flowing here. In this technology, to build pulse here, it needs the temperature requirement from the controller, from the operator, to monitor the temperature, to monitor the pulse, the coil current, and to monitor the pulse. Pulse detect in this area. When it will start to go in a reverse side, a pulse detector circuit will generate a signal. This will change according to the size of cookware. If the cookware is big, so it will cause to take excessive current, because secondary is taking extra load. when the cookware size is small, so it will cause small load to put on this coil. So if a small size cookware will come here in the center area, it will cause a less inductive reactance in this. When less inductive reactance will here, so when the magnetic field will collapse, the extra voltage will generated in the capacitor. So if the cookware size is full size, then this pulse size will small. So this pulse will be detected, and how it will be detected, we have here, sometime we have 741 series are used to check the coil voltage. What is the coil voltage? What is the pulse? Coil pulse, the return pulse. These will be calculated by the microcontroller. This pulse detect circuit will determines the size of the plate, size of the cookware. So it will adjust, and when in this portion, the Igbt will remain silent. In the first pulse, when the first pulse arrived, this current flow in the coil, and this is the resonant circuit. The reverse current will flow when it will go to negative at the zero degree. At that time, the MCU microcontroller will measure the temperature to generate the second pulse. This pulse, it will measure the temperature. How? From this temperature sensor. It will measure the temperature. It will check the temperature of Igbt. It will check the return pulse. Then it will also compare the required temperature. Suppose here is 10 degrees temperature. We need 200 degree temperature. When here is 10 degree, we need 200 degree. So it need to increase the temperature. When it requires to increase the temperature, it will give a pulses here. It will apply pulse here. So to add in this system, it will cause a pulse. So it will keep pulsing again. In this area, it will remain silent. Then when it will start again, the next pulse will arrive here. So this is current flow in the coil. So coil will taking the magnetic field, and it will cause to induce voltage in the cookware anytime. Suppose it is working at 600 degree, and he need 400 degrees. When the operator needed 400 degree, what will happen? This will reduce the pulse width. It will reduce the pulse width from here. First, suppose I say it was applying 20 milliseconds. Now it have to reduce the temperature. When it need to reduce the temperature, suppose first it was 20 degree, now he will start 15 degree until the temperature will reach at 400. At 600, it was giving 20 degree. When it need to reduce the temperature, what it will do? It will decrease the pulse width. When the pulse width decrease, the current flow in the coil will decrease. So when it will decrease, the flow of current and circulating current will decrease. So in this way, the induction voltage in the cookware will decrease. So temperature level will start decreasing. Another safety, auto power off. So when there is no plate, it will automatically power off. So these are controls, safeties, what a designer needs. There is a buzzer circuit. Then there is a fan, cooling fan. So we need 12 volt here, we need 12 volt here. Now our basic problems. The first problem, it does not power on. The first problem, no power on. Check fuse, basic. Then you have to check this power supply. Sometimes we have short circuit in the IGBT. Most of the time there is a problem in IGBT. Most of the time we have XL crystal. It's about 3.4 megahertz or 4 megahertz or 5 megahertz, 3.3 megahertz, 3.4 megahertz. It depends upon the designer and requirement of the circuit. It is called active touchpad sensor and watchdog system, and it is refreshed every time. Watchdog, what is watchdog? This is an active monitoring system. If any time the temperature goes high of the IGBT, it will protect. Temperature goes over temperature to the cookware, it will protect. And anytime we need power off, power on, it will keep refreshing in 20 millisecond interval, 50 millisecond interval. It depends upon the circuit. Most of the time we have no power, we have no heat, we have the same issues here. Okay, sometime IGBT is okay, processor is working. We have problem in operational amplifier, op amp. If operational amplifier is not good, it is not monitoring the temperature, it is not detecting the pulse, so we have to check this one. If the IGBT is bad, then we have to check the driver. So driver most of the time is transistor NPN or PNP, and sometime it is Darlington, and sometime there is IR2304 series ICs. They are driver. Sometime we have one IGBT, sometime we are using two IGBTs. So if two IGBTs, that time IR driver is used. In this system we studied, we have a coil and we have a capacitor which make a resonant circuit. Resonant frequency is determined by inductive reactance and capacitive reactance, and it is driven by IGBT. IGBT takes a drive signal through driver. Driver is connected to microcontroller. Microcontroller takes VCC from this local power supply, and it takes many inputs: temperature, cookware temperature, input voltage, current. All requirements and operator requirements, all safeties are monitored in this microcontroller, because here is a source code written by a developer who monitors all the system. So in the finally we take a drive signal, pulse drive signal, and this drive signal drives the coil to generate magnetic field. When this magnetic field is available, and in the silence of the IGBT, in that period there is a reverse magnetic field. When the magnetic field collapses from the coil, and it will make a pulse, the pulse detect circuit, that is from this operational amplifier, and it will feed it will feed the voltage. What are the voltage from the IGBT voltage? IGBT voltage, pulse detect circuit. So these will monitor the function because it is working as a closed loop. What is temperature? What is the size of cookware? It will determined by the pulse detect. So it will start switching to the IGBT, and IGBT will make pulses to take a firepower, to take a magnetic field, and this magnetic field will induce voltage in the iron core, in the ferret core, in the iron base of the cookware, and it will cause to increase the temperature in the base of this cookware. So in this way we are making a cookware, we are heating the cookware. 330 volt are applied here, and this resonant circuit will make a resonant frequency. So friends, if this video is good for you, if it is helpful for you, like, subscribe, share if you want. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.